Welcome to this session on predictive analytics. How can predictive analytics benefit you to find a right partner? What are the various dating websites all about, and what is the stats or science that goes behind the scenes to help you find a right partner? This can be used not just with respect to your dating websites, but also from matrimonial websites perspective. Even before we get started, there is a question which has come. Parmeshwari was asking on what is predictive analytics? Can it be applied to medical field? Just bear with me, Parmeshwari, on that. I'm going to explain or give you a few examples in the subsequent slides. First, we are going to discuss about what is predictive analytics? Why do we need predictive analytics? What are the various domains where predictive analytics can be used to give you some kind of a business inference, some kind of a solution to your business problems? And then we are going to look into this very example on how predictive analytics can be used to help you find a right partner. And then there's a case study on application of predictive analysis and how companies use predictive analytics for love match. So what is predictive analytics? I would say that there is one equation which is the most important equation when it comes to any business decisions, right? And that is y is equal to function of inputs, right? Your outcome, any outcome that you want to achieve, probably you want to increase your profits, your sales, how should you price up products, right? Whatever be your outcome that you want to achieve would be dependent on few inputs. What diseases you might get in the future depends on various input variables: your age, your gender, your genomes, the kind of lifestyle you're living in, your sleeping habits, your calories consumed, so on and so forth, right? So if you want to know the price of the used car, it depends on the miles driven, it depends on the make of the car, variant of the car, whether it's petrol, diesel, CNG, LPG, things like that, and multiple other factors. So this would be the most important equation when it comes to predictive analytics. Y is equal to f of x, right? So let us move on and try to understand a few more things about predictive analytics. So predictive analytics is all about using some kind of statistics, some kind of algorithms, some kind of data mining techniques, which is nothing but machine learning, right? And all you do is you look into your historical data, historical patterns, historical consumer behavior, and come up with a prediction. Consumer behavior. Are all the people within the age group of 20 to 22 based out of US, California, have a separate tendency to purchase iPhone 6 or iPhone 7, which is about to be released, right? So do they have any specific pattern or behavior associated, right? You can use your predictive analytics to look into that. I'm going to look into your questions towards the end, so please bear with me. Yeah. Another thing is machine learning. I'm sure you all might have heard about Google car, which drives without a driver. Google car. By looking into Google car, most of the other car manufacturers have come up with driverless cars. Toyota, GM, and all that are actually investing a lot on their research to come up with driverless car. How does a car identify on whether there is a pothole 10 meters ahead on the road? How does it understand that this braking should be of so much intensity pressure, right? You should not, or your vehicle should not by looking at the pothole, do a sudden brake, for example. If you were to take a left or right, your vehicle should decide whether it should take a left or right. If there's a red signal, it has to stop, and all those things should happen, right? So all these things happen using this simple concept called as machine learning. It's something like while you were a kid and your journey to become an adult, right? Everything was learning. That is called as machine learning, right? You teach, you tame people, and then they become well-educated, grown-up individuals. Patterns. This is used in your crime industry to some extent, right? Pattern matching. Is there a specific pattern of a person? See, if you take a photograph or if a CCTV is capturing a robbery in a bank, can that CCTV footage, video broken down, can that be broken down into frames of images? And can you go to the exact frame where you have the robber and try to identify his face and try to relate that face with the database of all the citizens of the nation? Can you match quickly and say, hey, these are the 10 matches, right? These are the 10 citizens whose features closely match with this particular image. And that way you will be able to, counter crime or get rid of the criminal very easily. Patterns. Scoring. If you search, say, online movies, for example, which website comes on the top, which website comes on the second page, third page, or second slot, third slot? These things are based on some kind of scoring algorithm, right? So you have the search engine optimization which happens, and all that uses these kind of algorithms and machine learning techniques in the backend. Visualization is the most important thing, right? If you have data with millions of records, how can I represent millions of records in a beautiful visualization, which gives me a lot of inferences rather than looking to those 1 million records? I want all those 1 million records to be represented visually so that I might make sense out of that. Yeah, Pramod, you're right on that. Recommendation engine. And then we have the predictive behavior. A person purchasing milk, bread, and diapers, right, probably is going to purchase baby food also. Maybe, right? So based on your previous buying behavior of all your customers, you will be able to predict on what would a similar kind of customer purchase, right? A woman or woman of the age 35 every week purchases milk, bread, and diapers. So she's most likely to purchase the other thing also. So any woman of that age probably would try to purchase the same kind of products in the future. That's predictive behavior. This is part of your recommendation engine, but engine is all about your online sales as opposed to your store sales, right? Physical store sales is associated with a technique called as association rules, whereas online sales is associated with your recommendation engine, right? Decision making, it will help you make a lot of decisions not based on your gut feel but based on crunching the data. So the decision that you take will most likely be right? For example, if you want to approve a loan, say a customer has applied for a loan, you want to approve that. What is the probability that he's going to default on the loan? Is he going to default or not? If he's going to default, then probably you'll not give him the loan itself, right? So you make judgment or you take a decision based on the data, not based on your gut feel. And then it will help you communicate. communication, your telecom industries, and also it's used to a great extent, right? Um, to tease out the terrorist conversations from the regular conversations of billions of customers around the globe. Think about that. The very thought about analyzing your audio files gives you goosebumps, is it not? Doesn't it? All right. So let us look into the predictive analytics life cycle to some extent. First and foremost thing is you try to formulate what is a business problem. And most of your time should be spent here in identifying the problem. If you end up identifying a wrong problem, no matter how good your data collection is, how good your prediction model is, how sophisticated it is, it's not going to achieve your business objectives. We are building the models, we are coming up with the statistics, we are coming up with the predictive analytics to ensure that our business sustains in the future, right? So for that reason, the business problem formulation is the most important part. And then we are going to prepare the data. That means we are going to identify what data we have to collect. We need to do some amount of cleansing of the data because we know for a fact that data comes from various sources. We get data from social media, we get data from YouTube, we get data from Pinterest in the form of images, we get the data from Wi-Fi logs, from the satellite logs, from your GPS and all that, right? How to bring the data to a structured format. That is your data preparation all about. Then you explore your data, you do the elementary analysis. For example, you look into your mean, median, mode, measures of central tendency, measures of dispersion, so on and so forth. And then you try to transform the data if you feel that the data is having weird patterns. When I say transform, you either take the log of the values or exponential things like that. Then you build your prediction model. Remember the equation y is equal to f of x. Your outcome is equal to function of inputs. Once you build the model, is your model even worth being used in real time? What is the accuracy of the model that you have built? Is your accuracy robust or is your accuracy very weak? Right? So you need to validate your model. Once you validate your model, you have to deploy your model in the business scenario, make it live, for example. And then you're going to frequently monitor the results, evaluate the results. And remember, this is an ongoing process. The moment you get the result, you're going to feed the results data once again into the model and enhance your model. So once you start off with your model, right, as and how you proceed, progress, your model is going to learn a new thing, right? Each time you have an output, it's going to learn new thing, right? And your model thereby becomes very robust. So here are the various uses of your advanced predictive analysis. So as I've told you, all right, it makes sense for me to just take these two questions because these two questions seem apt at this point of time. Association rule, Pramod says, is a method for discovering interesting relations between variables in large databases. Absolutely right, Pramod. So Pramod, when a customer walks into a retail store, he purchases a number of products. In that way, in any retail store, there could be thousands and, you know, 10,000s of customers walking in on a monthly basis. So you have a huge or larger database. Based on that large database, you analyze and see what are the various products which customers are purchasing in a single transaction. For example, I'm going to probably purchase a toothbrush and a toothpaste. So it makes sense for me to come up with a strategy wherein I'm going to stack these two and sell those two as a combo offer. or I'm going to place toothpaste and toothbrush beside each other in a rack. That's going to increase my sales. But association rules is used for generic purpose, right? You look into all the customer buying behavior, and then you come up with a generic strategy of placing products together, stacking them together, having your kids' toys in the lower rack and things like that. However, your recommendation engine is more specific. So if I go and search for iPhone 6 on Amazon, it's going to recommend me Samsung, probably Edge S6. However, if you go and search, probably it's going to show HTC, or it's going to suggest some other mobile or some other device, or probably completely different thing. Probably if you search for iPhone 6, it might throw you the cover for iPhone 6. So it's very specific. However, association rules is generic. Okay, I'll take this question from Harshal. Harshal has this question: how could my problem statement be wrong? In what scenario? Example, please. So let me couple this with the question which Parmeshwari has around medical things, right? Um, say you're performing clinical trial. Say you're performing a clinical trial. You actually wanted to check which drug and which research institute in which location will help you successfully complete a clinical trial, right? Given a drug, given a location, given a specific institute, research institute, which institute should you opt for you to successfully complete the clinical trial? However, if you have chosen a different disease altogether, probably you wanted to do this clinical trial on a person who has asthma, but you have selected patients who are diabetic, right? So your entire problem statement is screwed up there. Your problem statement should be smart, right? It should be specific. It cannot be generic. For example, if you're making a generic statement such as, I want to perform a clinical trial and I have this drug, I want to perform in this location, in this institute. You're being generic, right? So if I were to perform a clinical trial, I can perform on asthma patients, I can perform on diabetic, I can perform on people who have undergone some kind of a treatment, so on and so forth, right? But if your problem statement has to be specific, you would clearly mention that I want to perform this clinical trial on patients who have asthma. Absolutely, Pramod. Asking the right questions is very important. So you need to understand the problem, right? And that is the most critical objective. Yeah, you're right on that. Okay, back to our discussion. Advanced predictive analysis, campaign management, right? For my business to increase, should I do email campaign, or should I do social media campaign, or should I do an advertisement on my television, or should I advertise on newspapers? Which campaign is the most beneficial for me, right? For that, you can use your predictive analytics. Customer acquisition. So how do I acquire more customers? There is a customer who was with us, who has left us now, right? A customer was using AT&T. Now he is using Airtel, for example. How do I get back or win back that customer? Or can I even identify on when will a customer leave a particular service provider and go with another service provider? For example, say I'm with Airtel. Is there a probability that I'm going to go with Vodafone? Maybe, may not be. So that is your, I mean, you can use your predictive analytics to know that churn. Budgeting and forecasting. All right. Can you sitting here today forecast your sales for the next quarter, your profits for the next quarter, the number of products you're going to sell for the next quarter? That is forecasting, predicting what will happen in the future. Fraud detection. If I go swipe my credit card, right, can someone quickly tell me whether that's a fraudulent transaction or not based on fraud detection? That's another thing. Promotions, right? What kind of promotions are important, similar to your campaign management? How many coupons should I send? How much discount should I offer? Should I send them coupons worth 10% discount or 500 rupees off? Or what exactly is going to help me there? Pricing. Should the price of iPhone 7 be uh, 60,000 rupees, or should it be $1,000, or should it be $1,200? What should the price of that be? Given your product specifications, what is the price which the customers are willing to pay? That is your pricing analytics basically. And then your demand planning, right? Needless to say, in a call center, how many calls am I getting? Right, based on that, are my calls trend increasing or decreasing? If it's increasing, so do I need to hire more resources and things like that? Yeah, Harshal. So I'm just reading out the question which Harshal says. Okay, Harshal is happy with the explanation. So he says that the problem statement should be specific. Absolutely. Shah Tawsif has this question. Shah, where to bring optimization in predictive analytics? I have to do a project to do in the semester. How can I bridge the two together? So, optimization sits on top of your predictive analytics. You come up with a solution, right? Using your predictive analytics, you come up with a solution. However, how to optimize that solution given your constraints, right? That is optimization. So it sits on top of that. It's a different thing. Minimization or maximization problems using your linear programming, that is what you use in optimization. We can take it offline. um, Parameshwari says, isn't it similar to multivariate analysis? In multivariate analysis, you have multiple inputs and multiple outputs, right, Parameshwari? But in optimization, given the constraints, for example, my budget is only $1 million. Using $1 million, tell me what is the best mode, or best way of manufacturing 10,000 shoes, or a million shoes. I have $1 million. Yeah, what is the best way to manufacture 10,000 shoes? Now you look into various things, right? How many manufacturing plants do I need to have? In which countries do I need to have? Where am I going to procure my raw material from? How is the inspection going to happen? How many people will work? So on and so forth. So given those constraints, how would you optimize your solution? That is, well, absolutely, Shashwat. This is called as, Shashwat has this question: can we predict the employee who are going to leave the organization, or attrition planning in organization? Absolutely, Shashwat. That is called as workforce analytics. Even before an employee resigns, you can predict that this employee might most probably resign, and you take an action even before he or she resigns. Of course, based on whether he is important for your organization or not. Why predictive analytics is the next question. We are all mortals, right? We are not God or superhumans to be able to foresee our future. Hence, we need a mechanism to predict and see what will happen to my future. Being reactive days are gone now. You have to be proactive. Proactive with a certain probability that your prediction about the future is accurate. You need that confidence, right? Your management needs that confidence. What if I want to open a new store? Should I even open that or not? Market leader Target, they have suffered a lot of losses because they have launched, or they have ventured into Canada with their retail store. If I would have predicted upfront that, hey, Target, do not launch that, it's going to take you into losses, probably I would not have launched, right? What if statistics or predictive analytics or model or forecasting would have helped me in that, right? So it helps you save, trust me, millions of dollars, or if not more. Here we go. Forbes is um, a prestigious magazine, right? They say the top objective for between 2/3 and 3/4 of executives is to develop the ability to model and predictive behaviors to such an extent that individual decisions can be made in real time. As we are working now, I want real time. Just try out this. Do a Google search on purchasing any laptop or any mobile or any of your garments or anything for that case. Just wait for a couple of minutes and open your Facebook or any of the other website. You'll see similar product being placed as an ad there. That is real time. And you have various examples. We have Best Buy, Olive Green, RSC, right? All these companies have used predictive modeling in one way or the other to actually become more profitable. So Best Buy determined 7% of its customers who were responsible for 33% of its sales. So what? So you have to do segmentation, you have to do clustering. So clustering is a different statistical technique. I would not say statistical, it's a different data mining technique basically. So in that way, most of the companies have been profited. It can be used in trading, banking, e-commerce, retail, transport, IT, healthcare, so on and so forth, right? Healthcare, right? So since you have raised this question, in medical industries or medical sector, how can it be used? Nowadays, a lot of people are wearing health monitoring devices. I wear a watch, right, which is going to track my heart rate, number of hours I sleep, number of hours I'm sound asleep, number of hours I'm half awake, or number of disturbances while I sleep. It's going to track the number of calories I consume, number of calories I burn, number of steps that I take, number of floors I climb. Based on these things, you can build a prediction model which says that, hey, a person who lives this kind of a lifestyle will get these kind of diseases. Even before I get a disease, I can get a notification saying that, hey, you are prone to get a heart stroke if you continue living this kind of a lifestyle. Those kind of things can be used, right? Okay, Shashwat has this question. That means randomly occurred data need to tabbed only through predictive modeling. Yeah, I didn't quite get that question, but if I'm understanding your question correctly, yes, Shashwat. All right, this is an interesting segment where predictive analytics is being used now in dating. And these are all the various dating websites which we have, right? So I haven't used these, but I am pretty much aware of most of these things, right? For example, we have Tinder, right? Here you see Tinder. Tinder is an application, dating application, and they have launched their app in 2012, and in 2014 they have the data that 1 billion swipes per day were happening on their app. 1 billion apps swipes. That means if you do a right swipe versus left swipe, you'll see the picture or you'll move on to the next person, things like that. And they have launched and they are using a concept called as location based analytics, based on people who are staying in a particular location. It's going to do that and you have that app for iOS and Android. And they implement a technique called as freemium. Did anyone hear about freemium here? Freemium. They give you some amount for free. few features for free, and if you want enhanced features, they come for a cost. That is called as freemium. They'll ensure that they give you the basic features in such a way that you'll crave for the paid features. You'll crave. You'll actually want to use the other features, right? So again, here you do your analytics and say, hey, these features should be given for free, these features for a cost. That is when your uh, profits increase. That is when the free customers will become paid customers. That's based on, again, design of experiments and things like that. You can do that. Preetham has this question: how is it used in digital marketing tools like Adobe and Sitecore? How is it used in digital marketing? I can probably see that, right? For example, if for personalization, right? Okay. Yeah. So Preetham, what happens, personalized advertisement works in this way. It works on based on what you're doing, right? For example, you're a person who frequently searches about image processing, learning about something around images and photographs, or if you have a passion towards photography and things like that, then probably I'm going to market or I'm going to advertise you Adobe products. Just an example. Because you're searching a lot of things about photography. Probably after taking the photos, you want to do the cleansing part, looking into flipping the images, taking out the checkboard kind of things from your image and things like that, right? So that's called as personalization. But, it depends on what you're doing based on your data. And Google Chrome is free for your install. Facebook calling is free for your install. However, the moment it installs on your machine, it's going to save few files, which is going to frequently keep sending the information to Google, etc. Not the sensitive information, but most of the other information. That information is captured and then used for the marketing purpose. That is where Google gets a chunk or major chunk of its revenue, right? Based on Google Ads. Saswat has this question. Text mining. Yeah, it's captured using cookies, Sue. Text mining from social networking sites are data that occurred randomly, is what Shashwat says. Yeah, they collect the data from, or text mining is performed on your social networking sites. Not just that, based on your browser that you're using, that also captures a lot of data using the cookies. Absolutely. And Gyaneshwar has this question: what is fraud analytics? Fraud analytics means if I give you a loan, are you going to default or not? If I give you a credit card, are you going to default on the payment or not? Things like that. What kind of algorithms do they use for? Yeah, so I'm about to discuss that. So just a second. Let me quickly explain about these websites and what is happening on these websites, and post which your understanding about the algorithms might become a little clear. So we have a Tinder, which is an application, right, which was launched in 2012, and by 2014 there were 1 billion swipes per day, and they have launched this application in 30 different languages. That's tremendous. Then you have Badoo. They've launched this in 2006 in London, and now it's used in 180 countries. So look at the amount of data which these dating website companies are generating. And think about what would happen if you can help a person find the right match the first time. That is when, and there are a lot of people who have gone ahead with the long-term relationship, got married, right? Those stats are coming up. Let me show you those stats. It might be more interesting for you. And we have something called as match.com. This also is US based company which is launched in 25 plus countries. Then you have Blender. Blender is a geosocial GPS. It works on GPS basically. And this Blender uses another website called chemistry.com. Or sorry, Match.com uses another website called chemistry.com, which just conducts the surveys to help identify the choices of the people on whom do they prefer and things like that. And then you have OKC, OkCupid, I believe the complete name of that, and you have Hinge, eHarmony, and all that, right? Hinge is also an application, eHarmony. All right, eHarmony is a Los Angeles-based company which was set up in 2000. It's there in 150 plus countries. However, the key here is also data security. Say I join a dating website. My information, I would most often than not want it to be kept as a secret. I don't want someone to hack the password, look at my details, and do all sorts of things. So uh, privacy was once compromised when with respect to eHarmony, right? That dating website, and immediately they have sent email to all the customers asking them to change the passwords. Now, if this information becomes public, there might be celebrities, there might be politicians, right? And if that comes up in the media, it becomes a huge hue and cry. So for those reasons, data privacy is also the most happening topic as of now, because in this generation, because a lot of data is getting generated left, right, and center. Why do we use predictive analytics in dating domain? These are a few of the reasons. Look at how popular dating websites are. 1 in 10 Americans have used a mobile dating app or website. 1 in 10. In developed countries, it's very vastly used, right? 5% of all committed relationships in US began via something as simple as liking, swiping, or matching, right? And Tinder uses that swipe. So you say in Facebook, I like or share. On Twitter, you say tweet. On similar lines, with respect to Tinder, you say swipe. 5% of Americans who are currently married or in long-term partnership met their partner somewhere online. And among those who have been together for 10 years or less, 11% met online. Look at that. The amount of data that your mobile online dating applications are generating, number of visitors on the website, amount of data that they are generating. And there is a lot of potential, right, for coming up with predictive modeling and all that in these kind of situations. 90 or 57% of Americans with an annual household income of $75,000 or more know someone who uses online dating, and 40% know someone who met a spouse or partner this way. 59% of all internet users agree with the statement that online dating is a good way to meet people. So people are encouraging, people are using the application, they are happy with the service, they are happy with the security and privacy aspects. They're happy that they are able to find a perfect match. This is not India wherein your parents are going to search a bride or groom for you, right? We are speaking about a different country, a different culture, developed country which is developed in terms of economy and all that. 53% of internet users agree with the statement that online dating allows people to find a better match for themselves because they can get to know a lot more people. And this is the last. 11% of internet users say they have personally used an online dating site. There are a few more interesting analytical insights which are coming your way. Now, you can draw all these kind of interesting insights from the data which we have generated, data which we have collected, right? Women get 60% more attention if photo is taken indoors. So probably this is an interesting quote which you can mention on your websites or on your applications, right? And people will take, and men get 19% more attention if their photo is taken outside. Full body photos boost both sexes success by 203%. Posing with animals are the best friend. So these are all the insights, right, which one can draw just based on the amount of data that's getting generated. Look at the strength of the data. And this is a survey. Online dating industry made $2 billion. That's a huge amount. And your Match.com alone has 2.4 million paid subscribers, not the free subscribers. And Tinder is soon going to charge premium to get a bigger piece of the online market, right? Is there any question at this point of time? I wish to take 1 second. So Saswat has this question. Is it possible to do predictive analytics from pictures, audio, or audio-visual data? If so, how? Please explain in short. So yeah, I'll explain in this context, right? Yeah, people keep posting the images. And so can you establish some kind of pattern using the image? Can I say that if the human has these kind of features, he's going to be very selfish? Or if a person's image has these kind of features, does it say that the person is trustworthy or not? So you can do those kind of analysis. Using audio, if you and I are having a conversation, or is it a terrorist conversation, or does the conversation signal some kind of suicidal tendencies or something like that? That also can be analyzed using your deep learning. You use Python, you use OpenCV and all that for image processing, for audio analytics and all that, Shaswat. I'm not doing a deep dive on that. By the way, that's my core subject, video analytics and image processing. Anyways, yeah. Preetham has this question. Does predictive analytics use Hadoop NoSQL database, or it is decided by the tools? Hadoop and NoSQL databases are for your big data. If you have data which is unstructured, which is coming from different formats and things like that. If you have unstructured data, your statistical tools which are currently the most happening, such as R, right? Those can handle. You can cleanse the data, you can bring the unstructured data to the structured format, R, Python, and all that. However, if you have big data, then you need to use some kind of Hadoop, which is framework. It's a system, file system, distributed file system, or you can use NoSQL databases to get your job done. Yeah, Preetham. Hope that answers your question. Okay. So Hinge, right? Tailored matches based on your profession. So your profession would become your one input variable. Your education would become another input variable. Any other interest that you are playing cricket, watching football, playing American football, things like that, those become your X3 basically. Right? Based on all these input variables, you can predict on the nature of the person. Right? You'll have broad classification about the nature of the person. Similar to your vehicle, if you're driving a car, if you're driving it very fast, if your turning radius is too much, if your braking is sudden, you'll be classified as a risky driver. And if you're very smooth, if you're switching the lanes at proper times, if you're driving at a constant speed in a particular lane, if your driving radius is appropriate, you'll be probably categorized as a safe driver. Right? Based on whether you're risky or a safe driver, this information goes to your insurance company, and then your insurance company is either going to increase your premium or reduce the premium. Right? So in that way, you can use these values, these variables to predict on what is a category of a person. Then you have OKC. Provides a slew of questions to mathematically match you up with a compatible date. Right? And whenever you broadcast that message goes to the people who are in your neighborhood. All right. When are you available? Right. You can give a time range if you're traveling to a different country, that I'll be available from this date to this date, and I'm looking for a partner, things like that. And Blender is a game and finding app for following of 4 million users are there on this, right? So based on your location, based on your social network, it's going to check and connect you to the nearby single who is looking to connect with you, basically, right? So it doesn't do this way, right? If someone is in Japan and another person is in India, it's not going to connect these two people. It's going to connect people who are close to each other. Then you have Tinder. It's based on swipe right. It uses Facebook to determine mutual friends, interests, and locations. So it collects some amount of data from your Facebook. What do? You like a profile. If they like you back, you two can see more information about each other, chat, and make plans. Right. So this is good for data who values the privacy. So what happens? Not just that, you're also going to look into what kind of a person the opposition is, right? There can be a lot of fraudulent people who might register their profile and do some kind of you know fraud things or some kind of fraudulent things by uh, stealing away your images, posting them in some unwarranted locations and things like that. So a predictive modeling is going to first of all identify who are those people whom I have to remove from my system. Who are those people whose account should be disabled? Who are those people whom I should not even let them, register with me? Can I do that kind of a prediction? That is your predictive modeling all about. Yes, we can do that. And then you have eHarmony, right? Yeah. Here you have the higher odds of getting married. So what you can predict is basically, if there are two people who liked each other, what is the probability that they might get married also? Right? Or what is the probability that they might get separated? So you can provide this additional information to your uh, customers and say that, okay, you two profiles seems like, if you two go along well for another 2 or 3 years, you'll get married, kind of, right? Based on your historical data, and so on and so forth. Badoo is for your Spaniards, Italians, and French. So let us look into a case study of Match.com. So features. What are the features of this? Freedom of expression. We give singles the opportunity to express themselves through various free writing sections. And you can have close to 26 photos as well as selected preferences regarding the person you're searching. So the moment you provide these details, your preferences, it is going to quickly do analysis of the entire database and help you come up with the top 2 or 3 profiles. And how strong is your statistical algorithm that you have written to come up with these kind of selections depends on how many people are selecting one of those 3 profiles which you throw to them, which you predict, right? Because there are millions of profiles, I cannot go through each and every profile and select on my own. I do not have so much of time, for example. The model that you're going to build, the predictive model, will actually scan through the entire database, and it's going to quickly come up with analysis and tell you that, okay, based on your preferences, based on your images that you have posted, these are the top 3 matches. And if you select one of those, that means your algorithm is robust. Right? And then privacy issues. All communications between members happen through an anonymous email network, so no one can hack that. That is our assumption, right? But yeah, it's secure, but again, hackers are even more, what do you call, becoming even more thick-skinned, and They're also trying to hack most of the sophisticated systems. So the names and contact information of all our members, of all the members, right? Match.com are kept confidential until the member personally decides to share the information with a potential match. Now, what if a person convinces you to be a gentleman and tries to get the details, your personal details? And what if he then tries to circulate it among his friends group and things like that? It will be very disturbing, right? So how do I get rid of that? Here is where your fraud detection techniques come into picture. Fraud detection is a niche area basically, right? Who are the previous people who have done this kind of fraud? Do I have a similar kind of pattern with this person here based on his age, gender, sex, age, what do you call, location, so on and so forth, right? Every profile and photo is screened by the customers for the appropriateness. But here also, if you have some kind of historical data, you can use techniques such as decision tree. You can use techniques such as random forest. You can use techniques such as a neural network and all that, right? Data mining, supervised techniques basically to do that categorization on whether a person is fraud or not in various categories. And if you don't find someone special within 6 months, you'll be given additional 6 months for free. So those are all the various advantages that you have. And as I've told you earlier, Match.com uses Chemistry.com to do personalized surveys and get detailed preferences data. Once you have the preference data, again, it's going to search with the historical data of people who have already matched. So if person A and person B matches their profile and they go along for a long-term relationship or whatever be it, right? So this is a potential hit for me. So in this way, there'll be a lot of hit or a lot of success stories. You look into all these success stories as your historical data, and based on that, whenever new people search, you're going to look into that information, compare it with the existing database, and proceed with the further analysis on whether those two people are going to match or not, marry or not, and things like that. So here is an example. Person A is a potential match for person B, but with higher probability that person B is also interested in person A, right? It's not something like for person A, I'm going to show matches. Not just that. I also need to show person A matches. Matches mean I'll show him person 1, person 2, person 3 in such a way that there is an equal probability that person P also likes A, person 2 also, person 3 also likes E. In that way, I'm going to save a lot of effort, right? Otherwise, what happens if I'm going to show the profiles to person A, and what if person A likes person B, but person B doesn't like A? It's a waste of time. So how do I build those kind of models, right? Of course, there are a lot of challenges when you analyze the data. Validity of the data, right? People have the tendency to lie. How do I detect that? Skewness of the data. That means if you're handsome or if you're very beautiful, you might get a lot of invitations, right? And this is also analyzed. If there are a lot of unread inbox messages, then what happens? That particular person is high in demand. So that person's photograph is dropped, right? Dropped in the search basically. Then you have misbehaving users, right? So what happens if you are a person who is using abusive language, or if you're trying to come up with some obscene comments and things like that, you'll automatically be removed. Your account will be disabled. Your IP address and all that is tracked and disabled basically. And your algorithm is frequently enhanced as and how the amount of data gets generated. Do you know this? That Facebook can look at its users' posting patterns and moods in order to predict their future romantic relationships. Here is a case study there. This is what Facebook does, if you're not aware of until now. If in your profile you say that you're not into any relationship, right? Then if a person joins, there's a trend that they have noticed. 100 days before you meet someone, before you come in physical touch, contact, that will be the rate at which you'll post. 12 days before you're about to commit to a person, right? 12 days before, your number of posts increase. And day zero, when you're committed, it's so much, you are extremely happy. After that, obviously, it's going to come down. Facebook knows before you do when you're going to become a couple. Facebook knows you much better. It certainly knows long before you announce it on your relationship status, right? Even before you change your status to married or committed or things like that. Facebook knows that. So that those are the kind of possibilities of using analytics in your dating website. So here are references which have been referred to before coming up with this presentation. Now open to your questions. And one more thing, after your questions, or if you want to drop off now, please do take this survey. It's going to help us enhance the future webinars. So off to the questions. Shashwat has this question. Statistically, does distribution matters in predictive analytics? Absolutely, Shashwat. Whether your data follows normal distribution or Poisson distribution or log normal distribution or exponential distribution or Weibull distribution, whatever distribution we try, it matters in your analysis for sure. Shah has this question around behavioral statistics. Yeah, it's behavioral statistics, Shah. Sam, we are doing this webinar to ensure that we spread the awareness of analytics to people, right? On how analytics is shaping the world now. And you can register for a number of courses which Edureka has on advanced analytics and things like that, which will help you switch your careers or enhance your careers. So Shanta has this question. What are the models or algorithms we should focus on to specialize in predictive modeling analytics? So, it's difficult to just shortlist a 10 or 15 and tell you that, hey, these 10 or 15 you have to. But I'll put it in a different way. You need to know statistical analysis. You need to know forecasting. You need to know data mining, both supervised and unsupervised. And you need to know data visualization to some extent. Those are the things you need to focus upon. Shanta. Yeah, Shashwat. Thank you for that. Shashwat says it was a nice presentation. And he says, I wish it could be a bit longer in duration. So Sam has this question. I'm 40 plus in a totally different job. Can I switch careers at this time? Data analytics is at the peak of its, what do you call it? It's at the peak now, data analytics as a profession. But Sam, you need not switch your careers, right? In any profession, in any industry, in any sector, or in any domain, analytics is prevalent. It's only about learning and implementing in your own workspace. You need not switch your careers. There is nothing called switching careers if it comes to data analytics. Some tips and hints for interviews as a data scientist. Parmod, focus on statistical analysis, forecasting, and data mining techniques, along with your data visualization. Yeah, thank you, Shanta. Shanta says it was very informative and different from the usual sessions. Parmeshwari has this question. What is the difference between data analyst and data scientist? I would not see any difference. Those are just the different names, right? Data analyst and data scientist. There is no lot of difference. They're just terminologies. That's it. Is analytics can be utilized in chemical industry? Is it there? Absolutely. What kind of chemicals should you combine? to get a better product. For example, Nitish can use in that. You do help us find a role in data analytics if you learn through your online program. You need to, Sam, drop an email to support at Edureka, or at the end of the session when you take the survey, right? You can just mention this, because I'm a trainer. I might not be knowing that, but yeah, I know that the program is very good, which Edureka provides, but for this kind of additional information, you need to drop in an email to support at Edureka. All right, Nitish, thank you so much. Thank you, Parameshwari. Yeah. So, Sam, you can drop in an email to sales@edureka.co. All right. Thank you so much, friends. Do not forget to take the survey, and all the best for your careers, if at all you're planning for data analytics. Otherwise, also. All the best. Take care. Bye.